In this video, we're going to look at some of the fraction operations, especially how to add, subtract, multiply, divide, but also how to simplify some of the more complicated examples. The easiest operations to do with fractions are multiplying and dividing. For multiplication, you just multiply the numerators and the denominators straight across. So you do perform the operation on both top and bottom. So 1 times 3 is 3, 2 times 5 is 10 for this example. Division is actually very similar. We just add an extra step. You need to multiply by the reciprocal instead. A lot of you learned this as keep, change, flip. So if you have a division problem, they could also write this as a fraction, so 1/2 over 3/5, same thing. You keep the first fraction, you change the operation to multiplying, and you flip only that second fraction. And then you do the same thing that we did above, you multiply straight across. So 1 times 5, 2 times 3. And then make sure you do try to simplify those fractions after you get your answer, of course. So comments for this, you do not need a common denominator when multiplying or dividing. I see a lot of students try to get a common denominator first. It won't make your answer incorrect, but you are adding extra work and spending more time on doing something that you don't need to. So here are two quick examples that I'll work out with you. On the numerator here, we have 2 times 5, so my answer is going to be 10 on top. And then in the bottom, we have 3 times 7, so the answer is 21. These do not have anything in common, so I cannot reduce that fraction. It's just done. For this next one, I want to do one step before I go into the actual division here. I'm going to keep the first fraction, change it to multiplication, and flip this second fraction. So keep, change, flip, how most of you guys learned it. I usually just refer to it as multiplying by the reciprocal of this fraction. Now we can do the same thing we did above. 2 times 7 is 14. And in the bottom, 3 times 5 is 15. Nothing to reduce, so that's our answer. Adding and subtracting is where it gets a little bit trickier, especially when we start doing this with algebra expressions or rational expressions. So for these, we do need a common denominator. So get a common denominator first, and then the other thing that's tricky is you only perform the operation on top. With multiplying and dividing, we did the operation on top and bottom. A lot of people try to do that for the adding and subtracting fractions as well. So notice with this example I have written out, we're looking at the denominators and we're trying to find the smallest number that both of them go into. And in this case, they both go into 10. So I look at the fraction on the left and I figure out what I need to multiply the top and the bottom by, because you have to do it on top and bottom or you mess up, you change what the fraction is actually worth. So 5 times 1 and 5 times 2 gave me 5 over 10. And for the fraction on the right, I'm trying to get the denominator to equal 10. So I'm going to multiply the top and the bottom by 2 in this case. So 2 times 2 is 4, 5 times 2 is 10. Once you have this common denominator, only add or subtract the numbers on top. So 5 plus 4 is 9. I see a lot of students do the same thing in the bottom and they end up with 20 and then they have changed their answer and gotten it wrong as a result. So make sure you only add or subtract the numerators of your fractions. Okay, the first example I have here, both of these denominators can go into the number 6. So I'm going to multiply the fraction on the left by 2 over 2. So I'm just going to write the 2 off to the side to indicate what I'm multiplying by. So 2 times 2 is going to equal 4. And 2 times 3 is going to equal 6. So we've kept our fraction the same. It has the same value. It's just in a different form now. The fraction on the right, I don't actually need to multiply it by anything because it already has that denominator of 6. So now that I have a common denominator, only add the stuff on top, which will give me 5 over 6 instead. Next example, the smallest number that both of these go into is 12. So for the fraction on the left, I'm going to be multiplying this by 3 over 3 to get 12. And for the fraction on the right, I want 12 in the bottom, so I'm going to multiply by 4 over 4. Whatever you pick to multiply by, you have to multiply both the numerator and the denominator, because what's happening here is I'm multiplying by 1. 4 divided by 4 is equal to 1. So by doing this, I'm not changing the value of the fraction. I'm just going to change what it looks like. So first, the fraction on the left, I have 3 times 3, which is 9. And in the bottom, we have 3 times 4, which is 12. This one's a subtraction question. So on top, I have 2 times 4 is 8. And in the bottom, I have 3 times 4 is 12. Now that we have our common denominator, only do the operation on the numerators. So 9 minus 8 is 1 over 12. And that's the answer. Now let's talk about the process of simplifying fractions. So the first thing you want to do when you only have one term on top and bottom is find the GCF of the numerator and denominator. So find the biggest number that both of them have in common and the biggest variable power that they both have in common. In this case, 45 and 10 are both divisible by 5. So I pulled 5 out, and then the biggest exponent I have for my variables is the second power. So I pulled that out. Well, if you take 5x squared, if you take that GCF out of the original term, 45 divided by 5 is 9, and x cubed divided by x squared is x. So inside the parentheses, I'm left with 9x. For the denominator, if I'm taking 5x squared out, 10 divided by 5 is 2, and x squared over x squared cancels. So it's just 2 left inside the parentheses. Now that I have this matching GCF on the top and the bottom, the 5x squared parts can cancel, so you end up with just 9x over 2. And if you did it with the GCF, then there shouldn't be any more reducing to do. Maybe you didn't correctly identify the biggest number they both had in common. You might need to repeat that operation again with your new simplified fraction. One comment on here, I often have students say, do we need to simplify our answer? Yes, you should always be simplifying your answers, especially when we're doing assignments online. They usually won't accept your answer unless it's in the simplified form. So you might have done all of the work correctly and gotten the right number, like 4 over 2. But if you left it as 4 over 2, instead of recognizing that that's just the number 2, most of the online assignments will not give you credit for your answer. Okay, starting with example 5. For the numbers, 20 and 5 are both divisible by 5. So I'm going to pull 5 out of both the top and the bottom. I have x squared over x to the first, so I should be able to take an x out of both terms. So then for what's left, if I take 5x out, that leaves me with 4x on top. And on the bottom, if you take 5x out, that leaves you with 1. You can write that if you want, but really multiplying by 1 doesn't change anything. So usually I would have just left this piece off. Now that my 5x over 5x matches and cancels, I'm left with just an answer of 4x. Again, you do not have to write 4x over 1. You would just write that as 4x. For example 6, we'll repeat this process. The biggest number that both 6 and 21 have in common is 3. So I'm going to pull that out of top and bottom. And the biggest exponent I can take out is x squared. So after you take 3x squared out, let's see what's left. 6 divided by 3 is 2. And x squared divided by x squared leaves nothing else. On the bottom, 21 divided by 3 is 7. And x cubed divided by x squared is x. Since the 3x squareds matching on top and bottom will cancel, our final answer is just the 2 over 7x. That's as simplified as this answer gets. So simplifying rational expressions, this is actually where I see students struggle the most with reducing their fractions. You still want to follow that process for factoring the numerator and the denominator, and then canceling out what you have for those common factors. However, the comment I really want to emphasize here is that I see too many people work with 9x plus 3 over 3, and they think that they can just cancel out the 3 on the top and the bottom. In that case, your answer would be 9x. But notice that does not match what we got by going through the process of factoring out 3 first, canceling the 3's, and then being left with 3x plus 1. That's a very different answer, in fact. So do note that you cannot just cancel one term from the top with one term from the bottom. It's a very common mistake people make. Go through the process of factoring and then only canceling the common factors that you have on top and bottom. So for the numerator of number 7, both of these terms have 3 in common. I'm going to take that out, which leaves me with x minus 3. And then in the bottom, the GCF of 6x squared minus 18x, I can take out 6x, and that would leave me with x minus 3. Well, in this case, the x minus 3's will cancel, but I can also reduce the fraction 3 over 6, because now that will leave me with just 1 over 2 if I divide both of these numbers by 3. So I end up with 1 over 2x for my final simplified answer. Next one, number 8, again, please do not cancel the 2x's on the top and the bottom. That does not work. That will mess up your answer. Instead, take out the GCF on top, which is going to be 2. And on the bottom, since there was just one term, there was nothing to really factor or cancel out there. So on the bottom, I still just have 2x. But now I can cancel the 2 from the numerator and the denominator, which will leave me with x plus 2 over x instead. Notice how different your answer is from if you would just cancel the 2x's out of the top and the bottom. I will mention that, especially for a multiple choice question, sometimes this answer might get rewritten by splitting the numerator. So you could think of this as x over x plus 2 over x as two separate fractions. So that would be fine, because then you could reduce the x over x to equal 1, and then the other fraction doesn't reduce, so it would stay as 2 over x. So that's an alternative form of this answer that would be acceptable. It's important to know how to do things like that, especially for multiple choice tests, because they might not have left their answer in this form. But generally in this class, this is what I would prefer for your final answer. And that's it for the notes on how to work with fractions. Thank you, guys.